course, ecosystems, we're bringing in the abiotic stuff. Lots of things, not just those energy and nutrient cycles, but the sunshine, winds, ocean currents, variations in climate, fires, all these things. Different ones, different types of living things have different tolerances. And so certain settings will be what's just right for them. Also need to keep in mind the whole life cycle. What an adult can tolerate is not always something that the young can handle. So we need to keep in mind the whole life cycle, stimuli, something may be able to live but not reproduce under certain conditions. Bermuda, an island roughly offshore from Charleston, South Carolina, has a number of types of ocean creatures that we normally see in the Caribbean living there. They're able to live there, but it never gets quite warm enough for them to enter their reproductive cycle. So all the ones in Bermuda are babies that got carried off by the Gulf Stream and ended up on Bermuda, and they're not actually breeding there. Now there are of course some things that do breed under the conditions of Bermuda, but some things that's actually kind of beyond the limit for where they'd be sustainable. Temperature and availability of water are especially important. They're going to affect everywhere, and so key things to look at for ecosystems. Temperature changes where you are also. Earth, of course, is close to a sphere, no matter what silly things you might see on the line. And it's somewhat tilted for its axis of rotation relative to its orbit around the sun. That's why the stand for the globe has that kind of tilt to it to illustrate that. And this means that we've got a good deal of variation in how much sunshine different parts of the Earth's surface get at various times. The equator, sunshine's coming straight in at that, so it gets warm basically all the time. Near the poles, sunlight's coming in at a very low angle relative to the ground, much less energy gotten there. It's cooler. Yeah, you probably already knew it's colder at the poles than at the equator. But thinking about the importance of this. Different places, significant variation. We get the seasons and the difference between Arctic and equatorial conditions, all these relating to the tilt of the Earth and how much sunshine different places get. So we get our season pattern. This is labeled for the Northern Hemisphere. In December, if towards you is the sun, you are my sunshine, then what happens in December, Northern Hemisphere is tilted away from the sun. It's getting less direct sunshine. It's cooler. Conversely, the Southern Hemisphere tilted towards the sun. Sunlight's coming in more directly at it. It's warmer. Get to March. Now the tilt of the Earth is sideways relative to the sun. So everybody's getting it the same. June. Now we in the Northern Hemisphere are tilted more towards the sun. We're getting warmer. Southern Hemisphere is getting their winter. September, fall for us in the Northern Hemisphere. Again, we're sideways once more. Right at that point, everybody's getting things equally, but here in the north, we're moving towards being tilted away, and the south is moving towards tilted towards in the northern fall. Atmosphere. It's important. Breathing. It's good for your health. Don't forget to do it. So, supply of oxygen, carbon dioxide for photosynthesizing. It's also key protection, blocking high energy radiation from space. keeps things more even in temperature than would be the case without air, like on the moon. All our weather, and the key player that is in well-being, life on land, basically is only possible because it rains and water is supplied. Wind also moves things around. Seeds, spores, other small things, flying creatures. Wind is also the main driver of the ocean currents. And of course, the ocean currents are moving things around big time in the ocean. But living things aren't just passively getting whatever the air gives them. We're also giving back. We're affecting the levels of oxygen, of carbon dioxide, things like that. Climate is the long-term pattern of average weather. Both an average, say, year-round average temperature for some place is, let's say, about 55 degrees Fahrenheit. Okay. But does that mean that it goes back and forth between, say, 70 and 40? Or between 105 and 5? The range and variability is also something important to know as well. Now, climate, long-term, weather is the day-to-day variation. If you want to know, do I need to bring my umbrella tomorrow? You're talking about the weather. If you want to know, do I need to own 5 umbrellas? That's talking about the climate. All sorts of things go into the weather. Climate tends to change slowly under natural conditions. And this means that organisms are able to adapt, whether it is by developing tolerance for different conditions or by moving. And of course, this could be actual one organism getting up and moving, or for things like plants that can't do that, the seeds growing in places one way or the other depending on the change. We also see variation depending on things such as, already mentioned, north-south, where you are you near the poles, near the equator? But also, are you in the mountains or lowlands? Are you up on a slope or in a flat place? What types of plants? Do you have lots of water? Water has high heat capacity. It warms and cools very slowly. So if you've got lots of water nearby, temperature tends to be more stable. If you don't have much water around, temperature can vary much more. Are you way out in the middle of land? Are you close to the edge? Different precipitation, different places. In the tropics, it's warm, lots of water is evaporating from the ocean, and it can rain relatively quickly. Right near the equator, things being very warm, you tend to have rising air. As air rises, it cools off, makes clouds, and eventually you get the rain. Okay, now you've got air, rain fell out already, so that air is relatively dry, moves on out away from the equator, and eventually tends to sink down somewhat near 20, 30 degrees north and south. Sinking air gets warmer as it goes down. Warmer makes it easier for it to evaporate. So you tend to get drier with sinking air, and we get the zones of the deserts in those areas. Again, towards the interior of land, things tend to be drier. Near the oceans, we tend to get more humid climates. No, not always. There are places where we have desert right near the ocean, depending on our particular climate patterns. This is seen, for example, along parts of the north coast of South America, west coast of South America, Southwest Africa, some of the desert Southwest into Mexico. Also, mountains, air can't go through, so the air goes over the mountain, and as it goes up, again, cools down, and we get clouds, often rain or snow on the mountain. Air goes on up, down the other side, lowering, it's warming, drier. So the side of the mountains towards the winds tends to be cloudy, well watered. Downwind from the mountains, you tend to get dry areas. Here's a diagram version of that rain shadow. Moist air rising up, rains a lot, lots of stuff growing there, lots of rain. Down the other side will tend to be drier desert. Sometimes even you get dry areas down low at the base, but up towards the top of the mountain you have a more rich growth, and so you have what are sometimes known as cloud forests on into the mountains in areas with this pattern.